and that you don't end up running 12 volts through a 5-volt reference circuit and blowing out the PCM. Ask me how I know. Hey guys, welcome back. Steve here with 6-Star Automotive again with my trusty 15 Outback. I was doing some training with the guys this last week, and I had an idea for another video. Before we get started, like, subscribe, bell, join me as we talk about the 5-volt reference. So just like with the 5-volt reference circuit, I asked the same questions as everything else. What is it and why does it even matter? Computer modules need a known stable voltage to measure their sensor inputs accurately. So I have my U-scope connected to the 5-volt reference in the map sensor on this car. Let's take a look real quick. So you see here it has a stable 5 volts. It's like 5.04 or something. And that's good. You want to see, that's what the computer needs. It needs stability. It needs to see a nice solid line. The 5-volt reference is it's a regulated supply voltage that comes from the PCM. The PCM drops the voltage from that 12 or 14 that it gets from the alternator, and it pushes it through a voltage regulator and puts that out as the reference circuit. The sensor takes the 5-volt reference and it manipulates the voltage either through resistance or through some other means to send a signal that is less than 5 volts back to the PCM or computer. In this case, we're looking at the map sensor. So I guess before we do that, why is it 5 volts? I guess that's important to understand. Why is it 5? Why isn't it 12? Why isn't it 3.3? Why is it 5? So historically and practically, 5 volts is the sweet spot. It's high enough above electrical noise to be measured clearly, but it's also low enough to be safe for most electronics, most all electronics, and reduce the amount of heat in the system. Another important thing to recognize about why it's at 5 volts is that when you crank a car, you're already at 12, 11.8 or whatever, maybe sometimes even 10 point something volts. And when you're cranking it, it loads that down, which lowers the voltage. And then the computer is basically baselining all of its sensors off of the voltage that it gets during that time. So you can have the voltage go really low, and then your sensors could get their baseline from a really low voltage. If the baseline is supposed to be 5, then it's extremely unlikely, basically impossible for it to get below 5 volts while it's cranking. I mean, it won't crank. So it's safe to have it that low. If you tried to have it at 12 volts, then as soon as you had that voltage drop, it would change the baseline of all your sensors and everything would freak out. So that 5 volts is great because, again, signal noise down at the bottom, higher voltage that's more varied at the top based off of load and other things, and that 5 volts is a very easy way to keep it in that area and keep it stable. So common sensors that use 5-volt reference are usually 3-wire transducers. So map sensors, most mass airflow sensors will have 5 volts, throttle position sensors, pedal position sensors. Any sensor that uses a potentiometer or a sweep is going to use 5 volts. A lot of resistive sensors will use the 5 volts as well, like fuel temperature, fuel level, air temperature. Modules don't read or they don't interpret resistance or ohms. They can only interpret voltage. So the resistance is what's happening in the sensor, like a fuel level sensor. The resistance changes based off of the potentiometer and the arm that swings in the fuel tank. So as that arm swings, it moves that potentiometer through a different amount of resistive tape or whatever it is in that sensor, and then that changes the resistance going through. So that will then change the output voltage. So these systems are usually rather protected through their design. So if there's ever an open or a short, I mean, opens are never really a big deal, but if there's ever a short in that circuit, the computer is designed to either shut off the 5-volt reference circuit, or it will have like an internal resistor to drop it to ground. So that way it doesn't damage the voltage regulator inside the computer. It doesn't always work, but I think the majority of the time, like the engineers know, it's more likely that you're going to short to ground or get an open than like a short to power or something like that. So if you do end up having a short to like 12 volts or battery voltage, that can absolutely damage the 5-volt reference circuit inside the computer, and you got to be careful. That's why the power probe and stuff is really important, to be very mindful of what you're using and that you don't end up running 12 volts through a 5-volt reference circuit and blowing out the PCM. Ask me how I know. So I'm going to move this wire from the 5-volt reference circuit to the signal wire, and let's see what this guy does. So now we have 1.5 volts. We're sitting at hot idle. I'm going to give this thing some revs, and let's see what happens to this signal. I probably should change my time base a little bit here. Let's move this back over, not 1 second. There we go. How about 500 milliseconds? Let's take a peek at that. See what that looks like. So if I move this back to a 1 volt, let's do this one more time and you'll see what I'm talking about. See how you see a lot more definition. You know, it takes up more of the screen, so we can see. If I just bring the RPM up, see, that's interesting, right? So if I just bring the RPM up slowly, you don't actually see much of a change, but if I snap the throttle, you see that drastic change in manifold pressure, and that's what this guy's for. So the map sensor works. I'm getting a little bit into the weeds. I mean, understanding how map sensors work and mass airflow sensors and all this stuff is not exactly what this video is about, but map sensor and MAF sensors are used to determine the air-fuel mixture and the load of the vehicle, which helps also to determine the ignition advance and stuff like that. So complicated, but not necessarily into that right now. It's just the understanding the 5-volt reference and how those signals are manipulated in order to tell the computer what it needs to know based off of what's happening in the real world. So before we finish, I want to kind of show you what a diagram would look like in a in a 5-volt reference circuit. Let's take a look. All right, so here I've got all data pulled up on this car. We're going to go to the diagrams. I like to use the interactive OE diagrams. Then we're going to go down to powertrain management, and we'll go to engine controls. I like to click on the diagram. That gives me all of the diagrams at once. And then in this case, you know, this takes a little bit of time. You're going to need to kind of scan through these. I've already kind of scanned through this already to save us a bit of time. And I found, if you look right down here, we're going to zoom in and we'll look at that manifold absolute pressure sensor right here. So the wire that I was on, if you look, is right here. This guy, I'm going to click on this wire and you can see the green and black wire is our 5-volt reference. So this one goes to the electronic throttle control body assembly. We go to the manifold absolute pressure sensor, the left tumble generator, and the right tumble generator. I can back up to see if it goes anywhere else. Doesn't look like it goes very far in this system, but it does show us which pin goes to the PCM right over here. That could be helpful. So like in this case, if we had a bunch of codes and maybe the code said right tumble generator, left tumble generator, manifold absolute pressure sensor, and electronic throttle control, you know, and all of these had problems. Interesting, the commonality we have here is that 5-volt circuit. So, you know, be mindful of things like this. So one of the problems here is that those diagrams don't always tell you exactly what's going on and like how, like what signals should be there exactly. So it can be a little complicated. I ended up calling AllData with what I was dealing with on this one just to kind of ask them if like, hey, is there a 5-volt reference kind of standard to get me through all this stuff? And unfortunately, if the manufacturer doesn't give them that information, they don't have it to give. So this stuff can be difficult. It can be difficult. I'm not gonna try and minimize that in the slightest bit. But I hope that these things helped in the commonalities in here, and think about that 5-volt reference circuit and the things that I explained, and hopefully this helps with the development of your own diagnostic processes. Sorry guys, thanks for watching this one. I really appreciate it. I hope it helps. If you have any questions, you know where to put them. If you like it, let me know, and I guess I'll catch you with the next one. And remember, you can always come by and experience the 6-star difference for yourself. Another thing that's really important with the 5-volt reference and why it's at 5 volts, another important thing to recognize about why it's at 5 volts is that